Hello students and welcome to the virtual Science 10 classroom again. Today we are going to be talking about balancing chemical equations. So there is a note package that accompanies this lesson that you may use to follow along if you so choose. Just to recall some of the concepts that we've gone over so far, a chemical reaction is a reaction where one or more substances or substance is changed to a new substance or substances. So remember, chemistry is the study of change. A reactant is the substance that is about to react. Okay. If we're going to make an analogy about baking, this is like the reactants are like the ingredients of a recipe. So you get your flour, you get your, there is an I in there. I do know how to spell ingredients, but apparently I'm having issues with my writing. Shocker, I know. All right, so the reactants are the substances or substance that's about to react. They're like the ingredients of a recipe, like you set out your flour and your eggs and your milk and your baking powder and your flavoring, but you haven't mixed them up yet. The products are the new substance or substances that is or that are produced or created through the reaction. So this is like the final product of a recipe. So in other words, it's the cake you just baked. Cake. Okay. So when we're talking about chemical reactions, we also have to talk about the law of conservation of mass. It's actually the law of conservation of mass and energy. We spoke about the energy piece in the physics unit about how energy is conserved. It's either transferred or transformed, but it is neither created nor destroyed. And the same thing happens, or the same thing holds true about mass. Mass is neither created nor destroyed. You can't just somehow all of a sudden gain a bunch of mass out of nowhere. It has to come from somewhere. And you also just can't have mass just spontaneously disappear. Poof, gone. That doesn't happen either. It has to go somewhere. All right, so when we are talking about chemical equations, we need to account for all the atoms that are present before and after. They don't just all of a sudden have 2 copper atoms and somehow magically make 3 in the products. There has to be 3 copper atoms involved before and after. Just like you can't have 2 copper atoms before and all of a sudden have none after. The copper has to go somewhere. All right, so when we're talking about the chemical equation, I just want to review some of the symbols that are used. So this arrow, this means something is produced. So it stands for produces, or more correctly, it yields. Scientists like to use fancy words to say the same thing. Yields means it is produced. If we have a plus sign, it stands for plus or is added to. All right. If you see a symbol with an arrow and it has something like heat written on it, or an arrow that has light written on it, or an arrow that has elec, which stands for electricity, written on top of it, that just means that that the reaction needs to have heat, light, or electricity added to it in order for that reaction to occur. I forgot to mention that with my first arrow. If you see a little symbol like this, that means solid. L stands for liquid. And G stands for gas. These are the 3 states of matter that you've learned about in previous courses, but there's also a fourth one, I can count, which stands for aqueous. Okay, so aqueous is a state of matter, and that's an O in between the E and the U. Aqueous is a state of matter where something is dissolved in solution. Okay. And you'll talk more about that if you go on to Chem 11. The other thing we need to talk about are the coefficients that occur or just the kind of chemical equation. So here is a fully balanced chemical equation. And we have these subscripts that we've been using when we've put together a chemical compound. So aluminum is 3+, oxygen is 2-. We did crossover method and got aluminum 2O3, Al2O3. But all of a sudden, when you see this, there's these numbers in front of the elements and in front of the compounds. And these are called coefficients. They are what we use to balance the equation. And they are the number in front of the element or compounds. These are the things that we can change. We do not alter ever the subscripts in a compound when we are balancing. They are set. Al2O3 is aluminum oxide. We are not going to adjust the amount of aluminums or oxides in that compound when we are trying to balance. So the coefficients tell you how many of each unit are present, and they are what we use to balance an equation. So this one here means there is 4 aluminums. This number here means there's 3 oxides. Now for every oxide, there's 2. So it's 3 times 2. So there is 6 oxygen atoms present in that one little unit that we see right here. Okay. This coefficient means there's 2 aluminum oxides. Okay. So that means there's 2 times 2. So there's 4 aluminum atoms. And there's 2 times 3, which is 6 oxygen atoms, because there is 2 Al2O3s, okay? So if there's 2 of these compounds, that means there's twice the amount of aluminums and twice the amount of oxygens that you see in the compound. Okay. The other thing I've already kind of touched on, and I've made a bit of a mess of my notes here, so I'm just going to delete some of that noise out of the picture, but the subscripts are these numbers here, and they have to do with the amount of atoms of each element that are in a particular compound or molecule. I have a big warning sign here. I've already said it. I'm going to say it again. I'm probably going to say it even more later. You do not change the subscripts when balancing. Don't do it. You'll want to. Don't resist the urge. You only adjust coefficients. Okay. So, a balanced chemical equations have the same number of atoms of each element on both sides of the equation. Why? Because the law of conservation of matter, which is the law of conservation of mass and energy, stipulates that nothing is created or destroyed. So it's the law of conservation of mass. You might hear it be called law of conservation of matter. Really the same thing. So again, when balancing, never change the subscripts. I've already said it. I'm going to keep saying it. Only change the coefficient. Okay. So let's look at an example here. So I'm going to write out a word equation. We're going to go through the entire process of going straight from the words all the way to the balanced chemical equation. So if you have sodium bromide react with chlorine gas to produce sodium chloride and bromine gas, what is the chemical equation? So we have sodium bromide plus chlorine gas reacts to produce, we can put a little arrow there, sodium chloride. I'm going to kind of squish my words here to fit it in. Chloride and bromine gas. So, and bromine gas. Okay, so here's me taking the important stuff out of that equation. So the first thing that you do is write out the chemical compounds. So it's going to be a little bit of a review from the previous lesson of making compounds. So we have to find sodium on the periodic table of elements. It's Na. The charge is Na1+. We have to find bromine, because that's what bromide is when it's not in it. So it's Br1-. So it's a 1+ and a 1-. We're then going to use crossover method. We're going to have 1 Na and 1 Br. And because we're lazy chemists, we don't write our ones. And that's what sodium bromide looks like. We look up chlorine gas, and chlorine is a halogen. So any of the halogens and any of the atoms that end with the ending gen, so hydrogen, nitrogen, oxygen, and all the halogens, which is the second to last group on the periodic table, if they're by themselves like this, for anything other than the gens, you would just write its chemical formula and move on. But if it's a gen, meaning it's a halogen or its name ends with gen, it's never alone, there's always two of them. It's a weird thing. It has to do with their outer shell, their valence electrons and their stability, and how they just will never be found just completely by themselves. So that's something that you just have to remember. The gens are the halogens plus nitrogen, oxygen, and hydrogen. If they're by themselves like this, meaning that they're not in a compound with any other atom or element, there's still going to be two of them. Okay. If this said something like plus magnesium, well, magnesium doesn't end with the ending gen, and if you look it up in the periodic table, it's not in that second to last column beside the noble gases. It's not a halogen, so it would just be plus Mg. And that's it. You wouldn't put a little subscript 2 there, you would just leave it as is. But if it's any of the halogens or any of the atom or elements that end with the ending gen, you can't just leave it by itself. There has to be two of them. Okay. And now we're going to do sodium chloride. So you look up sodium, again, you've already actually looked it up, it's Na1+, and you look up chloride, which is chlorine, which is a halogen, it's 1-, and then you're going to do crossover method again. Okay. So there's going to be 1 sodium, right, for every 1 chlorine when you make or when sodium chloride is formed. And again, because we're lazy chemists, we could technically write those little ones there, but we're lazy chemists, we're embracing our lazy chemists, and we're not writing them. Okay. And then it's plus bromine gas. So bromine doesn't end with the word gen, but then when you look it up, bromine is in the halogen group. So when it's by itself, it is going to be plus Br, but because it's a halogen, there's two of them. All right, so I think I just actually did step 2. This was step 2 up here, and this, what I wrote out here was step 3. So oopsie doopsie, should have put that here. So what I should have written up here was Na1+, Br1- plus Cl2 goes to Na1+, Cl1- plus Br2, just to kind of show you, but I kind of did that step 2 and step 3 all in one. I apologize for that. Okay, so now you're going to count the amount of reactants in the products and the reactants. Now, you don't have to do the table. There's more than one way to do this. I prefer just counting and going through it and adjusting as I go. But I'm going to show you the table method as well, because it kind of helps. So if you have a before and after, and list off all the things you have before. So you have a sodium before, you have a Br before, and you have a Cl before. And you count how many of each do you have. Well, I have an invisible 1 here, which means I have 1 sodium. I have an invisible 1 here, which means I have 1 bromine. And I have a subscript 2 here, which means I have 2 chlorines. Now you're going to do the same thing after. So after I have 1 sodium, after I have 1 chlorine, and after I have 2 bromines. So as you can see, although my sodiums are balanced, there's 1 before and 1 after, I have an issue that I spontaneously had a bromine, I had a bromide just spontaneously appear, and I had a chlorine spontaneously disappear, and that can't happen. We have to balance this. So what we're going to do is we're going to add coefficients. And where we add coefficients is we add them before. Okay, so these spaces I'm drawing, these are where we add the numbers. We do not touch anything that is in blue. So I'm just going to go through here. I'm going to rewrite it. You don't have to rewrite every single stage. You can work on just the one thing, but because I'm trying to write out the steps, really clearly show you where I go, it helps. Okay, so I'm not touching anything in blue. I've already created my compounds using crossover method, or I could use the math method I showed, I could use the diagrammatic method I showed, lots of different methods, but I've got my compounds and my elements formed. I'm not going to touch anything in blue, but I am going to add numbers where I see the red blanks. Now, technically, there is already numbers there. There is. We wouldn't write the compound. There is technically, oops, don't want blue, I want red. There is technically 1 sodium Br, 1 chlorine gas, 1 sodium chloride, and 1 Br bromine gas there. But we didn't write them because we're lazy chemists, right? We don't write the number 1. If they weren't there at all, we wouldn't write the compound at all. So there is an assumed 1 already there, but we know from our counting before and after that having 1 of everything doesn't work. We actually need a couple things more. Just like if you were trying to make a cake, you don't just have 1 cup of flour, 1 egg, 1 cup of sugar, 1 cup of sodium, of baking powder. That doesn't work. You have to have the right combination in order to produce this product of cake. So how I do my balancing is I just start with the first one on the left, and I look at what values I can add to make it work. Now, it's important to know that sometimes this is trial and error. You should be balancing in pencil first before you get really used to it. Sometimes the number you start out with doesn't work. Right now, starting with the 1 in this position didn't work for our balancing, so we're going to see if we can adjust it. So here I have 1 sodium and I have 1 sodium. I'm going to use a highlighter for this. I have 1 sodium and 1 sodium. That's balanced. I have 1 Br, and on the opposite side of the arrow, on the right-hand side of the arrow, I have 2 bromines. That doesn't balance. So what I need to do is I need to add a number in this spot to make it so I have 2 bromines. Okay, so now I have 2 bromines and 2 bromines, or bromides. My bromines and bromides are balanced. But because I put the 2 in front of the whole thing, it means I now also have 2 sodiums. So I'm going to go back to the beginning. Here I have 2 sodiums. I'm going to highlight my second pass. Now I have 2 sodiums. Here I have 1 sodium. So now I have to put a number in front of this compound to make it so I have 2 sodiums. Okay. And so now I go back and check again. I have 2 sodiums, I have 2 sodiums. I have 2 bromines, I have 2 bromines. I am now good for sodium and bromines. I can now move to the next piece, which is chlorine. And I have 2 chlorines here, and I have 2 chlorines here, because remember, this coefficient affects everything it's in front of. So there's 2 chlorines here. I now have, before and after, 2 sodiums. I'm just going to change the color I'm doing this in. I have 2 sodiums before and after. I have 2 bromines before and after, and I have 2 chlorines before and after. I am now balanced with that equation. And what's really important to do is to go back at the end when you think you have it, and go back and just double check everything to ensure that you haven't accidentally changed a coefficient and adjusted something without realizing it, because sometimes that can happen. So I have 2 sodiums, 2 sodiums, 2 bromines, because there's a little 1 there, and it's 2 times 1, 2 bromines. I have 1 times 2, so I have 2 bromines there as well. I have 2 chlorines, and I have 2 times the 1, I have 2 chlorines. So I have 2 of everything now. Nothing got spontaneously created and nothing got spontaneously destroyed. To put that in a picture, I'm going to try to do this. If I look at, because it might help, if you got it, just you're good. If I look at sodium and bromine, were my first ones, and chlorine, and this is my sodium bromide, and this is my Cl and Cl, so my Cl2, and they produced, sodium chloride plus 2 Brs. And each of these bubbles represents the atom or molecule. You can see that it's not balanced. So we had to add, we added a 2 in front of that sodium bromine, which means there was a whole nother sodium bromine here. Help if I got my color coding straight in my head. Okay. And then we also put a 2 in front of the sodium chloride. So we put a 2 in front of here, remember? So that 2 in front of that is actually the same as just saying, hey, there's 2 of these whole things. Highlighting skills need a little work. I apologize. There's 2 of these whole things. So because I put, this is the same thing as saying 2 NaCl, and this is the same thing as saying 2 NaBr. Now, if you count the number of yellow dots before and after, they are equal. If you count the number of green dots before and after, they are now equal. And if you count the number of chlorines before and after, they are now equal too. And that's how we can balance them. We needed 2 sodium bromides molecules to react with 1 chlorine gas molecule in order for this reaction to occur. It would not have occurred if we had only 1, because it could not create it the way it is. So I'm going to quickly go over how to balance how to balance the ones with polyatomic ions. So I'm going to say the reaction out loud. I'm going to write it out in word form. I'm then going to write it out in skeleton form. And then I'm going to balance it, right? So the reaction I'm going to do is calcium hydroxide reacts with sodium sulfate to produce calcium sulfate and sodium hydroxide. So it's calcium hydroxide reacts with plus sodium sulfate to produce, so there's a little arrow, calcium sulfate and sodium hydroxide. So I'm converting reacts with and the word and with pluses, and to produce is replaced with an arrow. And now I'm going to have to figure out what these compounds are. So this is a little bit of a review of how to go from the word to the formula. So I'm going to look up calcium, and it's Ca2 plus. And hydroxide, you're going to see it as an IDE and go, oh, it must be on the periodic table of elements, but you don't find a hydroxygen or hydroxine. It's not hydrogen, it's not oxygen, it's actually hydrogen and oxygen together, and this is one of those polyatomic ions. So you have to look at that that chart on the other side of the periodic table that I gave you, and look it up, and it is OH minus. Now, hydroxide and cyanide are the two polyatomic ions that end with that IDE ending that aren't actually single elements. They are polyatomic ions. So then you're going to look up sodium. Sodium is Na plus or 1 plus. Put my little ones in here. I'm a lazy chemist. I don't write my ones. And you look up sulfate, which is has that ending that is not an IDE ending, so automatically that should clue you in that it's on that chart. It's a polyatomic ion. You look up sulfate and it's SO4 2 minus to produce. And what's nice is that once you've already looked up the ions for the before reaction, for the reactants, you don't need to look them up again because you've already looked up calcium. Calcium is Ca2 plus. And you've already looked up sulfate, which is SO4 2 minus. And you've already looked up sodium, which is Na plus, and you've already 1 plus, and you've already looked up hydroxide, which is OH 1 minus. So now we are going to write out the skeleton equation by putting those together. And up until this point, we're actually just doing review. The balancing comes after we have that skeleton equation. So we're just going to use the crossover method. So how many calciums are there? There is 1. How many hydroxides are there? There are 2. So remember, when there's 2 of polyatomic ion, you put a bracket, OH2. Okay. Plus sodium. How many sodiums are there? There are 2. How many SO4s are there? There are 1. So we don't have to put bracket, bracket 1 because we're lazy chemists. Keep going. Right. So how many calciums do we have? We have 2. How many sulfates do we have? We have 2. So had I written that down, it would have been a 2-to-2 ratio, which could be simplified to CaSO4. 2-to-2 ratio can be simplified to a 1-to-1 ratio. And finally, how many sodiums do I have in sodium hydroxide? I have 1. I'm not going to write it because I'm a lazy chemist. How many hydroxides do I have? I have 1. And so it's going to be just NaOH. I don't have to put the bracket, bracket 1. I don't have to write it like this because, again, lazy chemist. Okay. So from here, I'm going to count how many befores and afters I have. And I'm kind of a wee bit lazy. I actually don't do the chart part myself, but it helps some people out. So we're just going to count befores. So how many calciums are there before? There is 1. Oops. And the reason there is 1 is because there's no subscript following it, because I was a lazy chemist and I didn't write it, but technically there was a little 1 there. So there's 1 calcium before. How many calciums are after? 1. I'm going to count the whole hydroxide ion all together. How many hydroxides are there? There's 2. So I'm not going to separate the O and the H because the hydroxide is also found after the reaction. So instead of trying to separate oxygen and hydrogen and balance them separately, I'm going to deal with the polyatomic ion as a whole before and after. So how many hydroxides are after? There's only 1. How many sodiums are there before? 1. How many sodiums are there after? 1. How many SO4s are there after? 1, not 4. That 4 has to do with how many oxygens are in the entire sulfate ion. How many sulfates are there after? There is 1. And if you look at this, you're like, it's almost balanced, and that's true, but it's not completely balanced. So we have to balance it because something is not completely balanced. It means the whole thing isn't balanced. You can't just say it's good enough. So I'm going to rewrite it here just so that it's a little bit cleaner than all that circling I would did up there. And I'm going to look at balancing it. Okay. So where I have an issues with my hydroxides, so if you look at the before, my hydroxides here, there was 2, but here there was only 1. And I'm going to remember that when I balance, I can only change the coefficients in front of the entire compound or element. I cannot adjust anything in this equation that is in black. I can only add coefficients. Now, technically, there is already coefficients already written and inherently understood to be there, and they are 1s. All right, so I'm going to look at this. There is a 1 here, which means there's 1 times 2 hydroxides. But here, there is a 1, and the 1 times the 1 does not equal 2. So I'm going to change that 1, and I'm going to change it to a 2. And so now I have 2 times 1, which is 2. I have 2 hydroxides after now. I have 2 before, and I have 2 after. So now I'm going to continue going through balancing. I have 1 calcium. I have 1 calcium. I have 2 hydroxides. I have 2 hydroxides. I have 1 sodium. I have 2 sodiums. Oh, oops, that doesn't balance. So I have to add something in front. So I'm going to add a 2. So now that I have 2 sodiums, and I have 2 sodiums. I have 2 sulfates. But here I have only 1. So something has to change. Oh, you know what? I messed something up. Here there's supposed to be a 2. Oopsie doopsie. I'm going to have to redo this part. I don't know where it happened to my thing. I'm not going to recut that video. I'm just going to redo the balancing portion. Because it was just I forgot to write a 2 down when I was doing that. And sometimes that can happen. So when you go to balance, you're going to end up, and it didn't actually go through that part, you're going to end up, it's going to be an endless cycle not being able to balance. So then you have to double check. Well, did I do everything right? And here, where I said there should be 2 sodiums, I forgot to write that there was 2 sodiums. So that changes everything. So that one mistake created a huge mistake the entire way through. So I want you to apologize for that, but we're going to go back through it and say, okay, well, now assuming that this equation I've written is right, which it is, we can now go and try again. So sometimes if you go through it and you realize that this isn't going to work, it really pays to go back to this step up here. I meant to do that in yellow, not blue, but it really pays to go back to this part here and make sure that this is done correctly, because if it's not balancing, it might have to do with how you formed them. Now, if you're given the skeleton equation, you don't have to worry about that step. And so we're just going to go back to balancing. So we have one Ca here, one Ca here, but we have two hydroxides here, and we only have one here. So again, we're going to go back and add that too. Okay. So then we're going to recount. We have one calcium here, two hydroxides here, one calcium here, two hydroxides here. We have two sodiums here, and we have two sodiums here, so we're good. And we have one sulfate here, and we have one sulfate here, so we're good. And we've rechecked the entire thing. Now, technically, there is a 1 here, a 1 here, and a 1 here. We don't write them in because we're super lazy, but if you were asked for the order of coefficients to balance this equation, you would write 1, 1, 1, 2, because that is the order of the coefficients used to balance this. So I'd like you to go ahead and try those instant practice questions that I included. Let me know if you have any questions, and I hope you guys are all doing well. Thanks, bye.